Okay, in our past sections, we've been talking about converting units, and we talked about area, and linear measurement. And in this section, we're going to talk about the Pythagorean theorem, the distance formula, and the equation of a circle, because they're all very, very, very closely related. So when we talk about right triangles, and those are triangles with a right angle or a 90-degree angle, there is vocabulary that you need to know so that you can talk about them properly, and about the different sides of the triangles have particular names, and then the relationship between those sides has a particular relationship and a formula that you need to know. So let's just dive into this. Here we have a picture of a right triangle. Remember, a right triangle is one that always has a 90-degree angle. That's why it's called a right triangle. And we have the two sides that are adjacent to that right angle are called legs. And a lot of times we'll label those as side A and side B. And it doesn't matter which one is A and which one is B, as long as you're using A's and B's for the legs. The side opposite of the right angle is always called the hypotenuse, and it is almost always denoted by the letter C. So if your sides are ABC, which a lot of our generic triangles we label ABC, then the legs are always A and B, and it doesn't matter which order is which, but it does matter that C is always the hypotenuse. And the reason that it matters is because those things are related to each other in a very specific way. The relationship between the legs and the hypotenuse is legs squared plus legs squared equals hypotenuse squared. Or if you're using A, B's, and C's, we would write it as A squared plus B squared equals C squared. This is the Pythagorean theorem. Very incredibly important that you know, so make sure that you memorize that. Let's work an example. This one says, starting from point a boat sails due south for 3 miles, then due east for 6 miles, then due south again for 6 miles. How far is the boat from point A? Okay, so let's draw this out. That would help us out tremendously here. So let's say right here is our point A. Okay, it said the boat sailed due south for 3 miles, so I'm going to go south for 3 miles. And then it went due east for 6 miles. So I'll put that there. And then due south again for 6 miles. It wants to know how far is the boat from point A. So if our boat is here, let's sail, then they want to know how far is it away from point A. So let me draw that in as a dotted line. Okay. Can you see that if I were to drop this down and over, that we would have a giant right triangle? And we know what this side of that right triangle is because we have drawn this in to be a perfect square here. So this side here must also be 6, and this side must also be 6, making this entire side 9. Now, I can figure out what the hypotenuse is of that right triangle, and that hypotenuse happens to be how far the boat is from point A. So we can start off with side squared, so 9 squared, plus the other side squared, which would be 6 squared, equals C squared. So 9 squared would be 81, plus 6 squared would be 36, equals C squared. So 36 plus 81 is going to be 117, equals C squared. And so C is going to be the square root of 117. Now this will break down because 117 is 9 times 13. And if we take the square root of both of those, the square root of 9 is 3. Square roots of 13 is equal to C. So that tells us that 3 square roots of 13 is how far that boat is away from point A to start with. Now, I said the Pythagorean theorem and the distance formula were very, very closely related, and they are. They're pretty much the exact same thing. It just depends on how you look at it. But let's practice working with the distance formula for right now. And I listed out here the distance formula for us. Anytime we're working with 2 points, x1 and y1, x2 and y2, then we can put it into this formula. x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Take the square root of that whole thing, and you have the distance between those 2 points. Let me show you how this works. First of all, we have point A, that's the point 0, 10, and we have point B, which is the point 0, 6. So this is going to be my x1, y1, and this point is going to be my x2, y2. I think it's important to label those before you go through this process, just so that you don't make any boo-boos in plugging numbers in. This is really plug and chug, and it's not difficult, but if you put something in the wrong place, then of course you'll make a mistake. So the distance between those is going to equal the square root of x2 minus x1. Well, x2 is 0 and x1 is 0. So that would be 0 minus 0 squared plus y2 minus y1. Well, y2 is 6 minus y1 is 10. You see, I'm just simply following the formula and nothing else. Equals the square root of, well, 0 minus 0 is 0, squared is 0. 6 minus 10, that would be a negative 4 squared. Negative 4 squared is 16, and the square root of 16 is 4. So the distance between those 2 points is going to be 4 units. Now what about one that doesn't work out so nicely? What if we had this one here, find the distance between point A and point B, where A is the point 4, 19, and B is the point negative 18, negative 7. So again, before we get started, I'm going to label x1, y1 and x2, y2, just so that I don't get confused plugging in the proper order. So the distance would equal the square root of, now we're going to subtract our x's, x2 minus x1, so negative 18 minus 4 squared, plus, now we're going to subtract the y's, y2 minus y1, so negative 7 minus 19 quantity squared. And now then it's a matter of simplifying. So we have the square root of negative 18 minus 4, that would be negative 22 squared, plus negative 7 minus 19, that would be a negative 26 squared. And when we square negative 22, we get 484. Plus, when we square 26, we get 676. So now it's just doing order of operations and simplifying this down. So 484 plus 676 would give us 1160. And the square root of 1160, well, that, if we break that down, that would be 4 times 290. So when we take the square root of both of those, that would simplify to 2 square roots of 290. So that would be our distance. And if it says, you're going to want to watch your directions really carefully, because if it says you type an exact value with radicals as necessary, then that means that they want this answer. They don't want you to do it out on your calculator and get a decimal equivalent. So be very, very careful about that. Okay, this one says a 25-foot ladder is placed against a vertical wall of a building, with the bottom of the ladder standing on level ground 9 feet from the base of the building. How high up the wall does the ladder reach? So let's see what we've got going here. We've got a wall here, and there's a ladder leaning against it. And then our ground comes out here, and I'll just make some squishies for the ground. Won't make it a nice straight ground. Let's see, what does it say? A 25-foot ladder. So our ladder here is 25 feet. Placed against the vertical wall of a building with the bottom of the ladder standing on level ground 9 feet from the base of the building. So that means this is 9 feet here. How high up the wall does the ladder reach? So we're asking for this side here. Well, once we understand that, now we can use the Pythagorean theorem, that formula, in order to find that third side of that right triangle. So if this is my right angle, that means that this 25 is my C value. So I would have, let's say, a squared plus 9 squared equals 25 squared, which would be a squared plus 81 equals 25 squared would be 225. And if I subtract 81 from both sides, we get 144. And if I take the square root of both sides, a will equal 12. So that ladder is sitting at 12 feet up the wall. That's kind of interesting. Oh, here's a really interesting one. This one says a door is 6 feet 6 inches tall and 24 inches wide. Can a 7-foot square piece of plywood be carried through the door? Well, as we've done before, we have to make sure that all of our units are the exact same thing before you can work with it. So no matter, just hands down, that's what we've got to do first, is make sure that all of our units match. So since the width is in inches, let's go ahead and figure out what the height of this door is in inches to start with. So if you'll remember your dimensional analysis, we started off with 6 feet, and we don't want feet, so we're going to put it on the bottom to cancel it out and put inches on top. We know that there are 12 inches in 1 foot, so that means that 6 feet is equivalent to 72 inches. Well, that door is 6 feet 6 inches tall, so if I add 6 inches to that, that's a total of 78 inches tall for that door. So let me draw this out as we go here. We've got our doorway, and the door is 78 inches tall, and it's 24 inches wide. They want to know if a 7-foot square piece of plywood can be carried through the door. Well, it can't be carried, long ways, or because that's not big enough. But how do I know that? Well, I know that because 7 feet, if I convert that over to inches, remember, put your feet on bottom so that they will cancel. And there are 12 inches in 1 foot. 7 feet is equivalent to 84 inches. So there's no way it's too wide to fit through the door. It's too tall to fit through the door. So we'd have to be fitting it through at an angle. So I really want to know what this diagonal of the door is to see if it'll fit through. All right, so that means that I'm looking at 24 squared plus 78 squared equals c squared. I need to find that diagonal, or that hypotenuse. So 24 squared is 576 plus 78 squared is 6084 equals c squared. So when we add these two together, we get 6660 equals c squared. Or if I just do the decimal equivalent, if I take the square root of 6660, that would be 81.61. So that tells us that this sideways is 81.61. So can an 84-inch piece of plywood fit through diagonally if the diagonal is 81 inches? No, it would be too big to fit through the door. And we can prove that mathematically. All right, now last thing that we're going to talk about in this section is circles, because actually the circle formula, if we look at it here, x minus h squared plus y minus k squared equals r squared. Doesn't that look very, very similar to the distance formula and the Pythagorean theorem that we've been working with? Well, that's because it's exactly where it comes from. Our formula, here's our circle. The circle is technically all of the points in the plane that are a fixed distance from a center point, HK. So that center point there, we call the center, of course. And if you go out the exact same distance in all directions from that center, then you would get that circle. And that same distance that we're going out from each time, that's fixed distance, is what we call the radius of the circle. Well, the relationship between all of that is x minus h quantity squared plus y minus k quantity squared equals r squared, where h and k represent that center and r represents the radius. So let's see what they're going to have us do with these circles. This one says find an equation of the circle having the center at -1, 6 and a radius of square root of 7. Well, remember, our generic form of the circle is x minus h squared plus y minus k squared equals r squared. Move that up a little bit now. If I know that we have a center at -1, 6, that is our h and k. So instead of h, we can replace that with -1. And instead of k, we can replace that with 6. And then it said we had a radius of square root of 7. So I can replace r with square root of 7. Now this just becomes cleaning it up. So this would be x minus a -1, we would say plus 1 squared, plus y minus 6 squared equals the square root of 7 squared, which would be 7. This is what we call our standard form of a circle. Okay. Let's see what else we have to do. Oh, if we can come up with an equation, then we should be able to go backwards, and we should be able to look at an equation and pull out the center and the radius. Now I want us to just pause for a second and look at the one we just did. And what do you notice about the 1 and the 6 and the h and the k? Do you notice that when it's in the formula, they're always the opposite sign as whenever we look at just the point by itself? That's because, remember, our formula, generic form of the formula, says x minus h and y minus k. So we're always pulling out the opposite sign. Keep that in mind as we go through this next one. This one says find the center and the radius of the circle, x minus 2 quantity squared plus y plus 2 quantity squared equals 37. We're supposed to find our center, which is that h and k, And we're also supposed to find the radius. Alright, well the center here, remember, is supposed to be x minus h. So what is our h value? That would be a 2. And this is supposed to be a y minus k, so what would our k value have to be? It would have to be a negative 2. And the radius, well, this position is r squared. So if r squared is 37, then what does r have to be? It has to be the square root of that, or the square root of 37.